Hello again, Math 112 students. This is Chapter 3 homework, Part 2. It's only 12 problems, a lot shorter than Part 1. I separated this out because it's very much a separate topic from the things that were covered in the first Chapter 3 homework, which was mostly about how to solve polynomials of any degree. This is about rational functions, not polynomial functions, but rational functions. So I wanted to separate this out as a separate assignment. So moving on with it, let's get into the content. If p of x and q of x are polynomials, then f of x equals p of x over q of x is a what? It is a rational function, provided that q of x is not the zero polynomial. So one polynomial over another, that's what defines a function as a rational function. And I think we talked about it before, that the word rational means that it will fit into our minds, that our rationality can grasp it. So anything that can be written as a fraction is rational and can be classified that way. So that's why these are written as a fraction. They're called rational functions. All right. So next question. If the limit as x approaches a of the absolute value of f of x equals infinity, then the line x equals a is a what? All right, let's talk about what that means. Let's get a look at it. So x approaches a. So let's just say this is a. And as whatever function we're talking about, as the x value approaches this number a, the value of the function, the vertical value, the y value of the function, at least the absolute value of it, is going to approach infinity. So in other words, whatever this function is doing over here could be doing whatever, but as it approaches a, then the vertical value of the function is going to infinity. Or it could be also going to, from the other side, could be coming from this side as well. Or it could also be doing whatever, but it could also be approaching negative infinity, because negative infinity squared, or sorry, the absolute value of negative infinity is still positive infinity, so that still fits this description. So the line x equals a is this line right here. That's the line x equals a. And we call that, when this is the case, we call the line x equals a vertical asymptote. All right, let me go to the drop-down menu and see if that's the choice. Yes, a vertical asymptote. Vertical asymptote is a vertical line that the function approaches vertically. All right. So next question. Find the domain of the rational function. The domain, remember, is anything that goes in any of the inputs, anything that can go in for x. Well, there's one thing that could make a rational function get strange, and that is if you have a zero on the bottom. You can't divide by zero. We talked about that in class the other day. So if we're trying to find the domain of this function, then we would say the domain is all x such that, so that vertical line right there, in mathematics it means such that, so all x such that x plus 5 does not equal 0. And then we could continue to do some manipulation of this, and then we could say, go further and say such that x does not equal negative 5. So the domain is x does not equal negative 5. Now, this is a great way to express it, but notice that this Math Excel question says type your answer in interval notation. So if x does not equal negative 5, how do I express that as an interval? That means it can be anything but negative 5. So it can go from negative infinity to negative 5. And I make sure to put parenthesis around the negative 5 because it doesn't include the negative 5, union, and then anything after negative 5 up to infinity. So this means anything from negative infinity to infinity except this non-included value of negative 5. So that's how you type it in interval notation. That these two things, this and this, mean the same thing. All right, number 4. Same situation we got going on here. The domain is all x such that x squared plus 3x minus 28 does not equal 0. I then go further to try to solve for x. So that's going to be x plus 7, x minus 4 does not equal 0. So I set both of those not equal to 0, and I get x does not equal negative 7 or positive 4. So this would be a good answer. But how do I express that as an interval? I say it can go from negative infinity to negative 7, parenthesis, union negative 7 to 4, parentheses, union 4 to infinity. And that means it's everything from negative infinity to infinity, except it excludes the values of negative 7 and 4. All right, next question, number 5. This question says to determine the domain and the equations of the asymptotes. All right, the domain here, we can see on the graph that all of these x values are represented somewhere in this curve. Same thing over here. All these x values are represented somewhere in that curve, except for this one. This one is nowhere to be found in that curve. It has everything except that. It's going to touch everything except negative 5. So the domain is x is everything but negative 5. X is not equal to negative 5. Now, as an interval, we've already gone over how to say that. Negative infinity to negative 5, union negative 5 to infinity with parentheses. The equation of the asymptote, the equation of this line right here is x equals negative 5. That's the equation of the asymptote. All right, this says to give the equations of any vertical, horizontal, or oblique asymptotes for the graph of that given function. So let's talk about those three kinds of asymptotes. Okay, the kinds of asymptotes that you're going to have in a rational function are going to completely be determined by the degree of the numerator versus the degree of the denominator. Okay, if the degree, let me get a better something to write here. If the degree of the numerator is greater than the degree of the denominator, then you will have what's called an oblique asymptote. And you find the oblique asymptote, find it by dividing the numerator by the denominator, and the result is the equation of the oblique asymptote. Oblique is also known as a slant asymptote. So slant asymptote would be like if we had something like this. So that would be the slant asymptote of that rational function. And that only occurs when the degree of the numerator is higher than the degree of the denominator. You find it by doing synthetic division, like we've talked about in the previous assignment. You divide the numerator by the denominator using synthetic division, and that result that you get below that box, you make a new polynomial out of it. And that is the equation of the oblique asymptote. All right. let's talk about these other asymptotes. You get a horizontal asymptote. So let's say this, if the degree of the numerator is less than the degree of the denominator, then you will have a vertical asymptote. I apologize, I said that wrong. Let me back that up. I didn't mean vertical, I meant horizontal. I apologize. If the degree of the numerator is less than the degree of the denominator, you have a horizontal asymptote. And that horizontal asymptote will occur at y equals 0. And that will always be the case. You'll have a horizontal asymptote at y equals 0 if what? If the degree of the numerator is less than the degree of the denominator. The degree of the denominator is higher than the degree of the numerator in that case. Okay. Another case that we haven't yet done is if the degrees are equal. If the degrees are equal, you will have, again, a horizontal asymptote. And it will occur at the ratio of the leading coefficients. That is to say, the leading coefficient of the numerator over or divided by the leading coefficient of the denominator. All right, so let me recap this, okay? If the degree of the numerator is bigger, you will not have a horizontal asymptote, you will have a slant or oblique asymptote. If the degree of the denominator is bigger, you will not have a slant asymptote, you'll have a horizontal asymptote at y equals 0. If the degrees are equal, you will again have a horizontal asymptote, but not at y equals 0. It will be at the ratios of the leading coefficients. All right, that'll become more clear, I'm sure, as we go over examples of when these things occur. We haven't yet clarified vertical asymptotes. Let's clarify that now. Vertical asymptotes occur, they always occur, no matter what, they always occur where the denominator equals 0. All right. I guess there is one exception. One exception is if the denominator cancels out, in which case you have a whole rather than a vertical asymptote. Okay. So hopefully that was all the full explanation of what you need. All right, now let's go through the problems, and maybe things will become more clear as we go through these problems. So first of all, let's get the vertical asymptote. The vertical asymptote will be when we set x minus 3 equal to 0 and solve it, and we get x equals 3. That's the equation of the vertical asymptote. All right, now we just need to compare the degrees to determine if we have a horizontal or oblique asymptote. The degree of the numerator here, since it's just a 5, that's like a 5x to the 0, so the degree of the numerator is 0. The degree of the denominator is x to the first, so the degree of the denominator is 1. So the degree of the denominator is bigger. And when that's the case, you have a horizontal asymptote at what? Y equals 0. And we don't have any oblique ones when that's the case. So that should answer our question. Let me go back and put those into the answer just to make sure. X equals 3. And the horizontal asymptote is y equals 0. That is the case. Next question. Determine the equations of all asymptotes for the graph of the function. All right, we can do that. All right, you get the vertical asymptotes by setting this denominator equal to 0 and solving that. You're going to get 2 answers. And you'll do a check mark on both of those. I'm not even going to do that because I know that you know how to solve that. You'll get a horizontal asymptote. Well, let me just back up and say this. The degree of the denominator is bigger, so you'll get a horizontal asymptote at y equals 0. Moving on. Number 8. Okay, vertical asymptote, you already know what to do there. What about horizontal asymptotes this time, or oblique? The degrees, compare them, what are they? They're the same. Since the degrees are equal on top and bottom, we have a horizontal asymptote. And where does it occur? At the ratio of the leading coefficients. What's the leading coefficient of the top? 3. What's the leading coefficient of the bottom? 1. So I have a horizontal asymptote at y equals 3. 3 over 1 is 3. Okay, same situation here. Get the vertical asymptote by setting that equal to 0, and that's actually already solved for you. So x equals 0 is it. That is the vertical asymptote. All right, this time the degree on top is higher. If the degree on top is higher, then we have an oblique asymptote. And how do we find it? By synthetic division. All right, so I'm dividing the top by the bottom using synthetic division. So inside the box, I have 1, -3, and 1. Outside the box, I set this equal to 0, and I solve it, which is already solved. And I put that solution as the number outside the box. So in this case, I'm putting 0 outside the box. And I do my synthetic division. 1 plus nothing is 1. 0 times 1 is 0. -3 plus 0 is -3. 0 plus -3 is 0. I'm sorry, 0 times -3 is 0. 1 plus 0 is 1. I disregard the remainder in this case. And I just take what's left. And remember, it always starts 1 less degree than what we divided into. So what we divided into was an x squared, so this is going to be x to the first. So it's 1x to the first minus 3. This is the equation of my slant or oblique asymptote. Okay, same deal with this one. I'm just going to give you one hint on this one. When you do your synthetic division to find your oblique asymptote, remember to use a placeholder for the x term. So 3, 0, and 5 go in the box. All right, this is a strange looking problem, isn't it? So let me tell you what this means. This means the limit of this function as x approaches 2 from the right. That little plus sign means it approaches 2 from the right side of 2. So it could approach 2 from either the left side or from the right side, but we're approaching 2 from the right side. So the question is like, where's the function going as we approach 2 from this way? As we get closer and closer to 2 from this way, is the function heading up to positive infinity, or is it heading down to negative infinity? And we know we have a vertical asymptote there because if we set x squared minus 4 equal to 0, we solve that, we get plus or minus 2. So we have 2 vertical asymptotes, one at 2 and one at -2. So we know we have an asymptote there. The question is, which way is the function going at that asymptote? And a good way to do this, you could do it in your calculator, but you could also do it by hand. What you can do is it's real simple. Just plug in something really close to 2 on the right side of 2. Just plug in like 2.001. And when you plug that in, see what happens. So if we do, we're going to get something, when we square that, we're going to get something a little bigger than 4, right? something a little bit bigger than 4 point something minus 4. And so when we do 4 point something minus 4, we're going to get a small positive number, right? Something like 0.000 something 1 or something like that. Point being, -2 divided by that is a large negative number. And that tells us that when we're on the right side of 2, we're going towards really far negative. All right, and that'll tell us the answer to the question. If we had gotten a large positive number, we would know that we'd be going to the positive infinity. In this case, we're going down to negative infinity, so that the limit is negative infinity. It would be the answer to that. All right, if this problem could have said, you might encounter a problem similar that says as x approaches 2 with a negative sign right there, and then it would mean we're approaching 2 from the left. So instead of plugging in 2.001, you could plug in 1.999. All right, again, as I said before, you could also kind of just plug this in your calculator for y equals, and then go to your table and look at all the values. You could set your table to tell you every 0.001 as the x scale, and then it's going to go up by 0.001 every time, and then look where 2 is, and go just a little bit below 2 and a little bit above 2, and you could see the values that way as well. That's another way you could go about it. All right, moving on to this last one. All right. We're approaching 3 from the left, so I would plug in, if I'm approaching 3 from the left, maybe I'd plug in 2.99 or something like that. So 3 over 2.99 minus 3. What's this going to result in? That's going to be a small negative number. So 3 over like negative 0.001 or something like that. And what's that going to be? 3 divided by a small negative number is the smaller that number gets on the bottom, the larger kind of this number gets. So it's a large negative number, which means as we approach 3 from the left, in this case, we're going down toward negative infinity. So the limit will be negative infinity. Now let me just show you how this could also work in your calculator. All right, I'm going to type in my calculator 3 over x minus 3 in for the y equals. I can hit a fraction button right there. 3 over x minus 3. Wish it would be a little bit more focused. Kind of hard to see, isn't it? And I could just graph it. That's another way I could do it. Let me get my regular zoom menu back. My zoom standard. Option 6. And you can see this way too. Like you can see as we approach 3 from the left, it's going down to negative infinity. You can hardly see that, can you? That's really not easy to see, is it? But you can kind of see it. All right. We can also do it if we go to the table. So we hit second graph to get the table. Let me go table set. Let me hit second window to set the table. I'm gonna let my table start at 3 because I want to see around 3. I'm gonna let my delta table, that means how much the table changes by each time. I'm gonna let that be 0.01. And then I'm gonna hit second table. And now I can see, man, you cannot see those, can you? I wish you could see this. Okay, maybe you can see it if I put it at an angle. All right. You can see there that at 3 is an error because it's dividing by 0. It's a vertical asymptote. It's undefined. The calculator can't think like that. So it says error. Approaching 3 from the left, that means we're a little less than 3, 2.98, 2.99, and so on. It's a large negative number. approaching 3 from the right. If we were doing it from the right, it would be 3.013. We get a large positive number. And so the limit there would, if it was a 3 plus, the limit would be positive infinity. All right, regardless, the answer to this one is, as we said, negative infinity. And that takes care of all the problems in part 2 of chapter 3 homework. So good luck on those problems. See you next time.